Students, today topic is cosine function and inverse of a cosine function, secant function and inverse of a secant function, then the properties of inverse of a trigonometric function. Now recall the old definitions: odd function, even function. Odd function and even function. Odd function means, let us take f of x is given function. F of x is given function. F of minus x is equal to minus f of x, then function is odd. Function is odd. Suppose f of minus x is equal to positive f of x, then function is even. In this case, cosecant, sine reciprocal is cosecant. Therefore, cosecant function is odd. Cosecant function is odd. Secant function, the reciprocal of cos function is secant function. Therefore, secant function is even function. Cosecant function is 1 by sine function. Sine function is odd. 1 divided by odd function is odd function. Secant function is even function. Why? The reason is cos function is even. 1 by cos function is also even. Therefore, even function. Next is the amplitude of a function is the height from the x-axis to its maximum or minimum. Now, the amplitude means cos theta is given, then theta is amplitude. Cos 2 pi plus theta is given, cos theta is amplitude. Cos of 2 pi plus theta is equal to 1 complete round. 2 pi means 360 degree. Omit 360 degree, then cos theta. Again theta is amplitude. Suppose sin theta is given, then theta is amplitude. Secant theta is given, then theta is amplitude. Okay. Now EX number 4.4. EX number 4.4. Find the principal value of number 1, secant inverse of 2 divided by root 3. Let secant inverse of 2 divided by root 3 is equal to theta. Now 2 divided by root 3 is equal to secant theta. Next, secant theta is equal to 2 divided by root 3. Secant theta can be written in the form of 1 by cos theta. 1 by cos theta is equal to 2 divided by root 3. Now, reciprocal gives cos theta is equal to root 3 by 2. Cos in terms of root 3 by 2 is cos pi by 6. Taking cos inverse on both sides, we have theta is equal to pi by 6. Theta is equal to pi by 6 is the principal value of the given secant inverse 2 divided by root 3. Hence the principal value of secant inverse of 2 divided by root 3 is equal to pi by 6. Next, subdivision number 2, cot inverse of root 3. Let cot inverse of root 3 is equal to theta. Root 3 is equal to cot theta. Cot theta is equal to root 3. Cot means 1 by tan theta. 1 by tan theta is equal to root 3. Now one by tan theta is equal to root 3. Tan theta is equal to 1 by root 3. Tan theta is equal to 1 by root 3. In terms of tan of pi by 6 is tan 1 by root 3. So taking tan inverse on both sides, we have theta is equal to pi divided by 6. This pi divided by 6 belongs to minus pi by 2, comma positive pi by 2. Range between minus pi by 2 and positive pi by 2. Hence, the principal value of cot inverse of root 3 is pi by 6. Subdivision number 3, cosecant inverse of minus root 2. Let cosecant inverse of minus root 2 is equal to theta. Minus root 2 is equal to cosecant theta. Cosecant theta is equal to minus root 2. Now cosecant theta means 1 by sin theta is equal to minus root 2. Taking reciprocal, we have sin theta is equal to minus 1 by root 2. 1 by root 2 is sin 45 degree. So in this case, sin minus pi by 4. Taking sin inverse on both sides, we have theta is equal to minus pi divided by 4. This pi divided by 4 belongs to minus pi by 2 and plus pi by 2. Minus pi by 2 and plus pi by 2. Therefore, the principal value of, hence the principal value of cosecant inverse of minus root 2 is equal to minus pi divided by 4 is hence. Next, question number 2. Find the value of number 1, tan inverse of root 3 minus secant inverse of minus 2. First, take first part and then second part Subtract second from the first, we get answer. Let tan inverse of root 3 is equal to x. Root 3 is equal to tan x. Tan x is equal to root 3. Tan in terms of root 3 is tan pi by 3. Pi divided by 3. So x is equal to pi divided by 3. X is first part result. This result belongs to minus pi by 2 plus pi by 2. Okay. Next, and let secant inverse of minus 2 is equal to y. Minus 2 is equal to secant y. Secant y is equal to minus 2. Y is equal to secant y is equal to minus 2. In terms of secant is 1 by cos a. Cos y is equal to minus 2. Taking reciprocal, cos y is equal to minus 1 divided by 2. This minus 1 by divided by 2 from the cos column minus cos pi by 3. This can be written as cos pi minus pi by 3. Pi is 180 degree. Therefore, taking LCM 3 pi minus pi is 2 pi. Cos 2 pi divided by 3. Taking cos inverse on both sides, we get y is equal to 2 pi divided by 3. Now, tan inverse of root 3 minus secant inverse of minus 2 is equal to pi minus first pi by 3, next 2 pi by 3. Denominators are same, therefore minus pi divided by 3. Hence tan inverse of root 3 minus secant inverse of minus 2 is equal to minus pi divided by 3. Subdivision number 2. Sin inverse of minus 1 plus cos inverse of 1 by 2 plus cot inverse of 2. First, take first part, then second part, adding we get answer. Let sin inverse of minus 1 is equal to x. Minus 1 is equal to sin x. Sin x is equal to minus 1 implies sin of minus pi by 2. Taking sin inverse on both sides, we get x is equal to minus pi divided by 2. This minus pi divided by 2 belongs to closed interval minus pi by 2 and a closed interval positive pi by 2. This edge is including, therefore this belongs to minus pi by 2 and a plus pi by 2. Let second part cos inverse of 1 by 2 is equal to y. 1 by 2 is equal to cos y. Cos y is equal to 1 by 2. In terms of cos column, cos pi by 3. Cos 60 is 1 by 2. Cos pi divided by 3. Now y is equal to pi by 3. y is equal to pi by 3. Pi by 3 means 60 degree belongs to minus pi by 2 comma plus pi by 2. Now the third part, cot inverse of 2. We cannot find the correct answer. Why? The reason is sin 30 degree, 45 degree, 60 degree and 90 degrees are on the tabular column. This is inside the plus table. Therefore we cannot find the cot inverse of 2. Therefore sin inverse of -1 plus cos inverse of 1 by 2 plus cot inverse of 2 is equal to sin inverse of 1 by 2 is minus pi by 2, minus pi divided by 2 plus pi by 3 plus cot inverse of 2. Taking LCM we get a minus 3 pi plus 2 pi divided by 6 plus cot inverse of 2. Subtracting we get minus pi by 6 plus cot inverse of 2. Hence sin inverse of -1 plus cos inverse of 1 by 2 plus cot inverse of 2 is equal to cot inverse of 2 minus pi by 6. Hence the result. Next question number EX number 4.5, sum number 1. EX number 4.5, sum number 1. Find the value of if it exists. If not, give the reason for non-existence. Sum number 1, solution number 1. Sin inverse of cos pi let sin inverse of cos pi is equal to x. Taking sin on both sides, cos pi is equal to sin x. Sin x is equal to cos pi is -1, therefore -1. In terms of sin of minus pi by 2. Now taking sin inverse on both sides, x is equal to minus pi divided by 2. This x belongs to closed interval pi by 2, minus pi by 2 and plus pi by 2. Hence the value of x is sin inverse of cos pi is equal to minus pi divided by 2. Substitution number 2, tan inverse of sin minus pi divided by 2 is equal to this is x. Let tan inverse of Sine minus pi by 2 is equal to x. Now tan inverse of this minus pi by 2. This can be written as tan inverse of minus sine of minus theta is minus sine theta. Therefore, pi by 2 is equal to x. This can be written as tan inverse of minus sine 2 pi plus pi by 2. 2 pi means 360 degree. One complete round. Omit the complete round. We get tan inverse of minus sine pi by 2. We know that sine pi by 2 is 1. Therefore, tan inverse of here 1 into minus 1 is minus 1 is equal to x. Now tan x is equal to minus 1. In terms of tan of minus pi by 4. Now x is equal to, taking tan inverse on both sides, we get x is equal to minus pi divided by 4. This belongs to closed interval minus pi by 2 and plus pi by 2. Hence tan inverse of sine minus pi by 2 is equal to minus pi divided by 4 is answer. Next, question number 2. Find the value of the expression in terms of x with the help of a reference frame. Reference frame. Solution number 1, sine cos inverse of 1 minus x. We know that cos inverse of x is equal to sine inverse of square root of 1 minus x square. This is formula. If 0 is less than or equal to x, less than or equal to 1, now put x is equal to 1 minus x. We have put x is equal to 1 minus x in the above. Cos inverse of 1 minus x is equal to sine inverse of square root of, put x is equal to 1 minus x. So 1 minus x whole square. 1 minus x whole square is equal to sine inverse of square root of 1 minus bracket 1 plus x square minus 2x. We know that a minus b whole square is a square minus plus b square minus 2ab. Okay. Now distribute this negative sign in the bracket. We have sine inverse of square root of 1 minus 1 minus x square plus 2x. This means positive 2x, 1 minus 1 cancel, minus x square. This is cos inverse of 1 minus x. Now the question is sin of cos inverse of 1 minus x. Therefore sin of cos inverse of 1 minus x is equal to sin of sin inverse of root of 2x minus x square. We know that sin inverse of sin for all real x, answer is only square root of 2x minus x square. Therefore 2x minus x square. Hence sin of cos inverse of 1 minus x is equal to square root of 2x minus x square is sin of cos inverse of 1 minus x is square root of 2x minus x square. Submission number 2. Find the value of cos of tan inverse of 3x minus 1. We know that tan inverse of x is equal to cos inverse of 1 by root of 1 plus x square. 1 by root of 1 plus x square. Put x is equal to 3x minus 1. In the above, we have tan inverse of 3x minus 1 is equal to cos inverse of 1 by 1 plus 3x minus 1 whole square, square root of 3x minus 1, 1 plus 3x minus 1 whole square. Now expanding, we get cos inverse of 1 by 1 plus 9x square plus 1 minus 6x. We know that a minus b whole square is a square plus b square minus 2ab is equal to cos inverse of 1 by 1 plus 1 is 2. Therefore 9x square here square root. Okay, 9x square minus 6x plus 2. Now the question is cos of tan inverse of 3x minus is equal to, here tan inverse of 3x minus 1 cos inverse of 1 by square root of 9x square minus 6x plus 2. Cos inverse of cos is for all real x, answer is 1. Therefore 1 divided by square root of 9x square minus 6x plus 2. Therefore 1 divided by square root of 9x square minus 6x plus 2. Hence cos of tan inverse of 3x minus 1 is equal to 1 divided by root of 9x square minus 6x plus 2. Next, question number 3. Find the value of Find the value of number 1, sine inverse of cos of sine inverse of root 3 divided by 2. There are 3 terms. Let sine inverse of cos of sine inverse of root 3 divided by 2 is equal to sine inverse of cos of sine inverse of this root 3 by 2 is pi by 3. Why? Sine inverse of root 3 divided by 2 is equal to x. Sin x is equal to root 3 divided by 2 in terms of sine pi by 3. Therefore x is equal to pi by 3. X is sine inverse of root 3. So this bracket becomes pi by 3, cos of pi by 3. This will be sine inverse of cos pi by 3. Cos pi by 3 is 1 by 2. This cos pi by 2 is 1 by 2. Now sine inverse of 1 by 2. Sine inverse of 1 by 2 is sine inverse of cos of sine inverse of root 3 by 2 is answer. Now the totally this is right hand side, this also left hand side. Now we have to take the part sine inverse of 1 by sine inverse of 1 by 2. This sine inverse of 1 by 2 is pi by 6. Why? Let sine inverse of 1 by 2 is equal to y. 1 by 2 is equal to sin y. Sin y is equal to 1 by 2. In terms of sin is sin pi by 6. Sin that is 1 by 2. So sin pi by 6. Taking sin inverse on both sides, we have y is equal to pi by 6. Now y is total answer. Therefore hence sin inverse of cos of sin inverse of root 3 divided by 2 is pi by 6. Hence the result. Next submission number 2. Submission number 2. Find the value of cot of sin inverse of 3 by 5 plus sin inverse of 4 by 5. This is very important problem for your examination point of view. First take this bracket. Let sin inverse of 3 by 5 is equal to x. 3 by 5 is equal to sin x. Sin x is equal to 3 by 5. Sin x is equal to 3 divided by 5. Sin x. Opposite side divided by hypotenuse side is sin. So ABC, opposite is 3, hypotenuse side is 5. We want to find a adjacent side by the Pythagoras theorem. Pythagoras theorem, AC square is equal to AB square plus BC square. Now BC square is equal to AB square BC square is equal to, we want to find BC square, okay, AC square minus AB square. AC square is 5 square, AB square is 3 square. Therefore 25 minus 16, 25 minus 9, 16. Taking square root on both sides, BC is equal to 4. BC is equal to 4. This side 4. Okay. Now tan x is, from the diagram, tan x is equal to opposite side by adjacent side, AB divided by BC. AB divided by BC. AB is 3. 3 divided by 4. This is tan x. Now next sine inverse of, let sine inverse of 4 by 5 is given, is equal to y. Sine inverse of, taking sine on both sides, we get a 4 by 5 is equal to sine y. Next sine y is equal to 4 by 5. Right angle triangle ABC, ABC. Opposite side by hypotenuse side is sine y. Here y, opposite hypotenuse. By the Pythagoras theorem, AC square is equal to AB square plus BC square. Now we want to find BC square. BC square is equal to AC square minus AB square is equal to 5 square minus 4 square is equal to 9. 25 minus 16 is 9. Taking square root on both sides, we get BC is equal to 3. This side 3. Now tan y is equal to, from the diagram, tan y is equal to 4 divided by 3. AB opposite side divided by BC is equal to 4 divided by 3. Now the question is, cut off bracket sine inverse of 3 by 5. Therefore tan x y cut off x is this, sine 3 by 5. Therefore cut off x plus y. Cot of x plus y means 1 by tan of x plus y. This cot of x plus y means cot of sine inverse of 3 by 5 plus sine inverse of 4 by 5 is equal to this cot x plus y. Now tan of x plus y, expansion 1 divided by tan x plus tan y divided by 1 minus tan x tan y. Reciprocal gives 1 minus tan x tan y divided by tan x plus tan y. Now 1 minus tan x is 3 by 5, 4. Tan y is 4 by 3 divided by tan x is 3 by 4 plus 4 divided by 3. Cancelling these two, we get 1 minus 1 divided by 9 plus 16 divided by 12. Now 0 divided by 25 by 12. 0 by anything is 0. Hence cot of sine inverse of 3 by 5 plus sine inverse of 4 by 5 is equal to 0. Next, question number 5. Day of 4. Question number 4 is, prove that number 1, tan inverse of 3 by 11 2 by 11 plus tan inverse of 7 by 24 is equal to tan inverse of 1 by 2. Prove that tan inverse of 2 by 11 plus tan inverse of 7 by 24 is equal to tan inverse of 1 by 2. Take LHS to prove RHS. LHS equal to tan inverse of 2 divided by 11 plus tan inverse of 7 by 24 is equal to tan inverse of 2 by 11 plus 7 by 24 whole divided by 1 minus 2 by 11 into 7 by 24. Using the formula tan inverse of A plus tan inverse of B is equal to tan inverse of A plus B divided by 1 minus AB. Formula is tan inverse of A plus tan inverse of B is equal to tan inverse of A plus B divided by 1 minus AB. Okay, now tan inverse of 2 into 24 48 plus 77 divided by 11 into 24 divided by 11 into 24 is 264 minus 14 divided by 11 into 24. Denominator cancel. Tan inverse of 48 plus 77 divided by 264 minus 14 is equal to tan inverse of 125 divided by 250. Next, cancelling these two, 125 is 125, 2 125 are 250. Tan inverse of 1 by 2. This is RHS. Hence tan inverse of 2 by 11 plus tan inverse of 7 by 24 is equal to tan inverse of 1 by 2. Next, question number 5. Prove that tan inverse of x plus tan inverse of y plus tan inverse of z is equal to tan inverse of x plus y plus z minus xyz divided by 1 minus xy minus yz minus zx. First let us take first two terms and then take third. Let tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy. Now take third term. Let tan inverse of x plus tan inverse of y tan inverse of z is equal to tan inverse of x plus y divided by 1 minus xy plus tan inverse of z. Now take tan inverse of this bracket as a, this z as b, tan inverse of a plus tan inverse of b. Again tan inverse of x plus y by 1 minus xy plus z divided by 1 minus x plus y divided by 1 minus xy into z. Using the formula tan a plus tan inverse of a plus tan inverse of b is tan inverse of a plus b divided by 1 minus ab is equal to tan inverse of, taking LCM we have x plus y plus z minus xy z whole divided by 1 minus xy whole divided by cross multiplying 1 minus xy. Next minus xz minus yz divided by 1 minus xy. Now tan inverse of denominator cancel, we get x plus y plus z minus xy z whole divided by 1 minus xy minus yz then minus zx or xz. Hence tan inverse of x plus tan inverse of y, this is RHS. Therefore tan inverse of x plus tan inverse of y plus tan inverse of z is equal to tan inverse of x plus y plus z minus xyz divided by 1 minus xy minus yz minus zx. Hence the result. Next question number 5. Find the number of solutions. Find the number of solutions of the equation tan inverse of x minus 1 plus tan inverse of x plus tan inverse of x plus 1 is equal to tan inverse of 3x. First, let first term and third term tan inverse of x minus 1 plus tan inverse of x plus 1 is equal to, using the formula tan inverse of a plus tan inverse of b is tan inverse of a plus b divided by 1 minus ab. Tan inverse of x minus 1 plus x plus 1 divided by 1 minus x minus 1 into x plus 1. Now the numerator plus 1 minus 1 cancel, is equal to tan inverse of 2x divided by 1 minus x square minus 1. A plus b into a minus b is a square minus a b square. 1 square is 1. Therefore, tan inverse of 2x divided by 1 minus x square minus of minus positive. Distribute this negative sign. Minus of minus positive 1. Therefore, we get 1 plus 1 is 2. Tan inverse of 2x divided by 2 minus x square. Now take first two terms, first and third term, we get this result. Now we have to take all these things. So left hand side tan inverse of, now tan inverse of x minus 1 plus tan inverse of x plus 1 plus tan inverse of x is equal to tan inverse of 3x. This is given. Now first and second, tan inverse of 2x divided by 2 minus x square plus tan inverse of x is equal to tan inverse of 3x. Tan inverse of 3x. Now this tan inverse of x goes to right hand side, we get tan inverse of 2x divided by 2 minus x square is equal to tan inverse of 3x minus tan inverse of x. Now right hand side, tan inverse of a minus tan inverse of b. Tan inverse of a minus tan inverse of b is tan inverse of a minus b divided by 1 plus ab. So tan inverse of 3x minus x divided by 1 minus ab. 3x into x. Right hand side tan inverse of 2x tan inverse of 3x minus x. Tan inverse of 3x minus x divided by tan inverse of A minus B divided by 1 plus, now divided by 1 plus 3x square, 1 plus 3x square, 3 into x square. Now left hand side and right hand sides are tan inverse of something is equal to tan inverse of something. Therefore, now taking tan on both sides, we get 2x divided by 2 minus x square. 2x divided by 2 minus x square is equal to 2x divided by 1 plus 3x square, 1 plus 3x square. Now cross multiplying 6x square, 2x plus 6x square, cross multiplying we get 1 into 2x is 2x plus 6x power 3, x into x square, x power 3 is equal to 2x into 2 is 4x minus 2x power 3. Now this negative sign of 2x cube comes to left hand side, 8x power 3 minus 2x minus 4x is 2x is equal to 0. 2x is common. This is a third degree equation. Therefore, there are 3 solutions. What are they? 2x common, 4x square minus 1 is equal to 0. Since 2 is not equal to 0, therefore x is equal to 0, 4x square minus 1 is equal to 0. 4x square is equal to 0 implies, no, 4x square is equal to minus positive 1. Positive 1. Why? 4x square, this minus 1 goes to right hand side. So negative 1 to into positive 1. So x square is equal to 1 by 4. Taking square root on both sides, we get x is equal to plus or minus 1 by 2. 1 by square root of 4, therefore 1 by 2. Now there are 2 solutions, plus or minus 1 and 0. Therefore totally 3 solutions. Hence the 3 solutions are These solutions are 0, minus 1 by 2 and positive 1 by 2. Today homework. Ex number 4.4, sum number 2, subdivision number 3. Ex number 4.5, sum number 1, subdivision number 3, sum number 2, subdivision number 3, sum number 3, subdivision number 3, sum number 4, subdivision number 2, 6, 7, 8 and 9. These are the homeworks. Any doubt? Study well. Any doubt? Reply the message. Thank you.